you keep going to art? Your son got your art skills.
Oh yeah, definitely. My art skills are terrible. But here's
Hey, you call your
is
son
terrible.
terrible at nothing?
Oh my
No.
goodness, Mr.
Wow, you're so
That was an indirect insult.
Mr. Ward.
Mr. Ward.
I didn't say he was any good. Alright. Hey, sit. Go. Get out of there.
I never got one.
I just found this on the floor, Mr. Ward.
Alright. Good.
Dang it.
Alright, now, first, here's what we need to do.
How come I never got one down?
Oh,
Yeah, I didn't get none either.
Sorry.
I didn't get one either.
Sorry.
Mr. Ward,
Sorry. I thought I finished.
first you don't grade the test.
Yeah, sorry.
He's
Then you
slacking.
don't give me a good grade.
Mr. Ward is slacking.
Alright. Okay, real quick.
Look, you need to stop looking at the camera. I'm not.
Alright, here's the idea. What we're going to talk about today, we're going to go through a couple different, stop, if you want to say this one. So, alright, what we're going to do is we're going to talk about graphing. So, we have a couple different topics with graphing. Number one, we got to talk about the leading coefficient test. This is kind of a review of pre-calc, because we're going to get into some stuff where we have to graph, like very difficult looking functions, and I want you to know all the shortcuts so you can draw the most generic looking picture you can, because we do need to look at drawings eventually. There's like major things with Calc 1 that we have to know how to draw so we can look at certain answers in certain spots. I'll explain that concept here in a minute. We're going to look at the leading coefficient test.
I can see perfectly. Drawing it.
Okay, so leading coefficient test, we'll go through that. Second thing we need to discuss, we need to look at the different forms of the intercepts. So different intercepts, x-intercepts, y-intercepts, we've already discussed that term. But the problem is we've never done it for like a polynomial or a rational function. So there's different things we have to do. There's the x and y intercepts, and so we'll look at zeros, we'll look at, so other than x and y axis,
Well, put it in.
we're going to look at maybe where the zeros are. So that's a part of the x and y axis. We're also going to look at any type of asymptote where you can't draw at all. Okay, those are the things we're going to do. Brown, sit down. So, those are my different topics that I want to discuss. Now, the other main bullets, other than those forms, I want to talk about the turning points and if there's any types of symmetry. Now, I think symmetry is usually earlier. I'm not going in order by any means on any of these. I'm just showing you things I look at when I graph. Like this is to get the most generic looking graph so it looks somewhat okay. That's what I want to discuss. Okay, we're going to do maybe one or two today. That's it. Then we're done. I'm going to pick very generic ones so you can get kind of a feel for how they look. So we understand how they're working. And then we're done for the day. So first one, let's do one where it's a quadratic. So let's go with something very straightforward. Let's go with like 3x squared plus 5x plus 2. Okay, this will be my function. We're going to learn to draw this. Now there's different ways we've learned how to draw. Question?
I'll see you after this. I'll see you in a bit.
Okay, all right, so there's different forms of graphing, what I want to make sure of. And so, like one way we've learned previously to do this, we've learned how to complete the square and do it like a quadratic, a normal quadratic. But I'm just going to show you the generic way of like looking at it, so you don't have to memorize every step, like where the vertex is and where it starts. Like we can just draw a very generic looking graph, and you go from there. Okay? It doesn't have to be exactly perfect because there's things we're going to learn later. We're going to add to this list that will make it easier to look at. Okay?
Can you just type in your calculator?
Well, yeah, but I'm trying to talk about we don't all have graphing calculators, right? So can we do this on a test when I give you no technology to actually graph?
Probably not.
So, all right. So first, to draw this, here's what I want to make sure of. When we're actually going through this, make sure that you're writing down all these steps. Put it on your graph paper, obviously, but in your notes, maybe make like little like key things like what we're doing, when we're doing it, so you understand like, okay, I'm looking for leading coefficient. Like, what does that mean? Like, what did I look at? What did I say? What were the big topics? So when we go to a more difficult problem, you know how to apply everything. Okay, all right. So so here's the first one. Let's go through the first step here. Let's go to the leading coefficient test.
Three.
All right. So leading coefficients. Well, obviously the leading coefficient for me is this term. The big thing I'm looking for is that it's positive. Okay, it's a positive 3. Now, what that means is since it's positive, I'm going to have a normal graph. If it was negative, my graph is the opposite, right? It's the negation, it's flipped. So this is positive versus negative. So this is a normal looking graph for what I'm going to be talking about. Now what I mean by normal is that the next thing I look at with the leading coefficient is what is the power?
It's 2.
It's a 2. Well, this is an even exponent. So I'm going to be drawing a normal picture for an even exponent. That's like the things I look at when I look at leading coefficient. Because it's positive, so it's a normal picture for an even exponent problem. Even exponents means the end behavior is the tails.
It's a parabola.
Yeah. So an even power is a parabola. It's like a little shoe. What that means is that the tails go the same direction. Even powers, like if it was a 4, if it was a 6, the tails are going to go in the normal direction. Since it's positive, the tail's going to end up going up. If it was negative, the tails go down. Does that make sense? Like that's what I'm looking at first. Now, are my tails in the right spots? No idea. But I know that they're going up at some point. Okay, does that make sense what end behavior is and what even exponents are? If it was an odd exponent, the tails go opposite direction by end behavior. That's where the tails end up going. Okay? You stand up again, you're leaving. So, you've been finally warned. So, all right. So there's your end behavior. Now, if you're drawing it on your graph, make sure you have the tails going up. Second thing, let's look at the intercepts now. Intercepts for this particular picture, I need to factor. So I'm going to look at my x-intercepts. So I'm going to look at the x-intercepts, and I'm going to try to graph these out. Okay? So to do this, to factor that thing apart, I'm using normal trinomial rules. So trinomials, I have to use 2 parentheses. The back symbol is a plus. So that means the operations in here are the same. I don't know what they are yet. I know they're the same because that's what the back plus sign is. And what they are is that they're both plus. The one in the front tells you they're both plus. Now, this would be more difficult if it was a polynomial. You'd have to learn how to factor polynomials like by grouping. Or you have to learn how to find those x-intercepts by other means. That's something we're going to look at on Monday. But x-intercepts I'm going to factor here, right? So I'm going to break up the 3x squared to be 3x and 1x. I'm going to break up the 2 in the back to be 2 and 1. And hopefully that makes the 5 in the middle, which it does.
It very does.
So because this is 3x squared, 3x, 2x means 5x's, and then 2 in the back. Now if you can't factor, maybe you'll have to do quadratic formula or something where it gives you the x-intercepts. So if you can't factor, maybe it's unfactorable.
I thought you meant like if you didn't know how to factor.
No. If it's not factorable,
Right.
maybe that's a better way to put it. Okay. So now in this case, what I need to do is figure out what would make each of these
You're not
0.
supposed to do that.
What numbers would make these 0?
1. Negative 1.
Negative 1 and negative
2/3.
2/3. How do you do that to set each of these equal to 0?
You just know.
Okay. So this is negative 2/3 and a negative 1. Now that I know that they're both negative, do you notice how close together they are?
Crazy.
Okay, they're really close because probably what happened is that this thing was orienting its way down, it turned around and went back up like that. So the tails are ending going up, but the problem is they're so close together, the vertex is probably right next to that. Okay? Now, how do I know if it's turning there or if it's passing through or those x-intercepts? What are the powers on these parentheses? 1. If they're odd powers, this is called the multiplicity test. It's a part of doing the zeros. multiplicity test. The multiplicity test tells me, am I passing through or am I bouncing off of it? I am passing through both x-intercepts because the power in each of those parentheses was a 1. If I factored it and there was more than one parenthesis that were all the same, I could put different powers on them. And maybe there's just like a power 2 back here when I grouped it. There's 2 of them, so then I would be bouncing off that x-intercept. We'll look at those on Monday. Okay? All right, questions at all about this so far? So that's what the zeros are. You have to look at the zeros, look at the multiplicity test, see if I'm passing through. Okay, now asymptotes. Is this thing a fraction? No, no asymptotes. It's a continuous function.
Wait,
If there is a fraction, we will have some form of an asymptote somewhere.
Can I ask my question now?
Okay, question.
Are you gonna make a video unboxing of your iPhone?
No.
You're not
So-
gonna record
Like
that?
BuzzFeed style?
Moving on. Okay, let's talk about turning points. This graph, to figure out the number of turning points, you take the highest degree term. Degree on this particular problem is a 2, and you subtract 1 off of it. So there is 1 turning point on this thing. It will turn 1 direction from its original location. So it was starting this upper left corner. It was coming down, and do you notice that it only turned directions 1 time?
Yes.
And then went the other direction. So it's turning once. Now this is not a set number. This is just a recommendation. Okay, last one, symmetry. If this thing is symmetric or not, we have to look at the powers.
It's not.
Okay, it is not symmetric. The reason being, the powers are changing as we go along this problem. So, as we looked at the powers, it went from even power to an odd power to an even power for my x's. Because I consider 0 to be even. Since it's changing powers, this thing is not symmetric. And what that means is if you look at the left and right side of the y-axis, we are not balanced.
If it was like 4 and then 2, and then it's
Yes.
0.
Yeah, then it would. Okay, questions at all about that? That's probably the generic look to that graph. That's what it is. Like that's what I'm looking to do. I'm looking at, do we know what those are? Now, the only thing I haven't found was the y-intercept. The y-intercept in my particular case, I actually drew through it, I just didn't tell you. Going back up here to the y-intercept, you just plug zeros into all the x's. And it ends up being a 2.
Yeah.
I happen to draw through it, I just didn't tell you. Okay, questions with all the parts we talked about?
Are we done?
We'll do one more and then we're done.
You promise? You swear?
Let's do 2 more.
Don't swear. No, I wanna look at his phone.
Okay,
Can we do 1.5?
It's got 3 cameras, doesn't it?
Yep.
That's crazy.
okay, let's go through the last one here.
Isn't it 1 camera? It's not.
No, this money,
Well, if there's 3.
Okay, last one, let's go with, I'm gonna go with the one that Brian, you were talking about earlier.
Short and sharp eye.
The camera.
What? Okay, anyway. Let's go with x to the 4th plus, or let's go minus, let's go with minus 9x squared
That's symmetrical.
plus, let's go with,
55.
yeah, let's go 8. I didn't want to.
That's symmetrical.
Okay, so we do have a symmetrical looking drawing here. Now, the reason why, if we look at the powers, my powers are all even powers, so this thing will be symmetrical.
I'm so smart.
That's something that we'll look at later. Let's do the leading coefficient test. So this should be your second drawing you're attempting. So,
positive 1.
positive 1 out front. That means this is doing a normal drawing because it's positive. Now, it's normal for the power of 4. So power of 4, because I'm doing the leading coefficient, power of 4, it's an even power, right? So the number, or the end behavior, the tails are going up. Both the same direction, it's an even power. And they're going up because it's positive 1. If it was negative, they go down. Does that make sense for leading coefficient test?
Yeah.
Let's factor this thing apart. All right, so now we're going to factor. Okay, so factoring, let's do x-intercepts. 2 parentheses, it's going to be minus minus. They're the same, they're both negative. That's how I know it. We're going to go x squared and x squared, and we're going to break up 8 to be 8 and 1. Okay? Now, this thing has 4 x-intercepts. How I know that is it literally has a power of 4, so in theory, it could hit the x-axis 4 times. Now, how I know it has 4? Because you're looking here, you're going, whoa, that's only 2. These can factor 1 more time. It's a difference of squares. Even though 8 is not a perfect square, we can treat it like it is and actually factor these using the difference of squares rules. So the difference of square rules, if you don't remember, when we factor, it's 2 parentheses, it's plus minus. You break up the x and x. The back number, you just take the square root of it. That's how you cheat it. I mean, if it was a 9, it'd be 3 and 3, because you take the square root of 9. So if it's 8, I just took the square root of 8. Now these are both numbers, these are weird decimals. They're almost the number 3 in theory. It's almost 3, it's like 2 point something. All right, now for this one up here, it's a difference of squares, plus minus, x and x, and then you break up 1, you take the square root of it, it's 1 and 1. So there is 4 actual x-intercepts. Now, the square root of 8, it's 2 point something, so I'm just gonna, so this is a negative 2 point something, 2 point something. This is positive 2 point something. This is negative 1, and that's positive 1. So I do have 4 x-intercepts. So negative 1, positive 1, 2 point something, and negative 2 point something. All right, so there's my 4 spots I'm crossing.
How do you know how far to go down? Or does it not?
Oh, like when I do start doing the loops? That's the thing we're going to add later. That's like what this chapter is, this chapter. We're going to add like little pieces.
Because we know it crosses through 8 in the middle.
Yeah, exactly. So like the highest point we're hitting, because since this thing is symmetrical, 1, 2, 3, 4, 5, 6, 7, 8, that's the y-axis, the y-intercept. We know the highest point, right? Or right now, that relative max point. But where I'm hitting the lowest point, that's what we're going to look at in the later sections of this chapter. Like, just add one more rule. Right? These are the rules we learned in pre-calc, right? We're going to add weird other things we can do, which is something, one of the rules we've actually did in pre-calc is how we explain this concept, the exact question you're asking. Okay, we'll get to that. That's coming later. Right now, we're just going to draw a generic picture of it. I don't know how low they go right now, unless we do those extra rules. Okay, so what are my powers in each of these parentheses? 1. They're all 1s, right? And there's no parentheses that repeats, so these will all be passed through. Because they're odd powers, we pass through those x-intercepts. So this is what we're doing. It's going down, it's coming back up, it's hitting its peak, coming down, coming back up, and kind of continuing on. So there you go. And it is supposed to be symmetrical. Now, how I know it's symmetrical is because it passed the symmetry test, that it has even powers throughout the whole problem, so it is symmetrical. Now, turning points. My highest degree was what, a 4? And we subtract 1. So it should have 3 turning points from its original direction. The left side, it was going down as I went from left to right. Then it changed direction once, changed directions twice, and changed direction 3 times. So it has a change of direction 3 because of the degree. That's why we actually use degrees in like algebra 2, is that tells me the turning points that we actually get.
For the turning point, it's the highest power.
It's the highest power, you subtract 1 on it. But now, again, it's just a recommendation. It doesn't have to do 3 turning points. It could.
Kind of like squeeze them.
Yeah. It's, well, no.
You disagree with
No, he's absolutely right. The word limit.
It's just a recommendation.
No. What, Brown, this actually comes back to what you brought up earlier. Like, how do we know those highest and lowest points? What we're doing is we're actually going to be finding a limit, right? That's what the word is. And the limit means you get approximately 2 from the top end and the bottom end. Like above the speed limit, below the speed limit, you just get close. That's literally what the word limit means.
Yeah, my mom says you can go 5 over and it's fine.
Yeah, she's literally right because you have to be close.
I call
That's
it 16.
literally what limit means. So when they're like, you're speeding, I'm within limit. The definition of limit means I'm either plus or minus by a certain threshold. That's literally what it means. That's why they give you a little give and take.
When I
Because
get
it's
pulled
what the
over, I'll be
definition
like,
of
I
limit
thought the speed limit was just a recommendation.
Pull up
That's what my
Webster's
teacher,
dictionary.
Mr. Ward, said.
Flip over to the limit page.
You explain what the definition of limit is, but don't be rude about it. All right. Hey.
That's what it's relative
And,
to.
yeah.
You just gotta write
Sorry.
every factor.
All right. Any questions with the topics? Now we have a lot of stuff to cover. Okay, so hopefully you have graphs.
Legal in Iowa?
We're gonna do a couple notes Monday. My goal Monday is to go through tests.
I don't know.
test scores because I'll go through them this weekend. I should finish them. I am not going to add the test scores into JMC until Monday because of I don't want it considered to be on the midterm.
There's a method.
If you want to know your score, I'll email it to you personally. I don't want to add it to JMC because then it'll look like it's on the midterm and you can't make fixes. Like we can't do a retake. That's why I'm going to add it Monday. If that makes sense.
Thank you, Mr. Ward.
It was already in the video.
I don't know if you can see it.
It was in there. I picked it.